Welcome back. Today we're starting a new section, 5.4. So in 5.4, we're focusing on dividing polynomials. And throughout this lesson, we're going to talk about two different ways to divide. Today we're going to focus on the way that you actually started way back in elementary school with long division. So before we dive into what it looks like in Algebra 2, let's just refresh our memories on what you've already done back in elementary school, and you saw this back in exponential algebra as well. So when I say divide 514 by 11, mainly you want to make sure, first of all, you can set it up using this structure, okay? And when I say long division, again, you saw this 2 years ago, so likely that is still sort of fresh in your minds. Now, with long division, again, we're going to review the process with just numbers first before we start throwing in polynomials. If you recall, the first thing you want to do is see how many times can this 11 go into that first piece. So how many times can 11 go into 51 without going over? And hopefully you can recognize it goes in 4 times, okay? 11 goes into 51 4 times without going over. And that's going to give us 44, right? 11 times 4 is 44. Well, the real goal is we want to see how close are we getting? How close am I to getting that number? So I'm going to subtract that off. 51 minus 44 is going to give me 7. Pull down the next number, and let's do this process again. So now I want to see how many times can that 11 go into 74. Well, 11 can go into 74 6 times without going over. That's going to bring me up to 66. And now again, the goal is I want to see how close did I get. Well, I got 8. Now, there's nothing else to pull down, and 11 can't go into 8 because 11 is bigger than 8. So really that means this process is finished. When you finish that process, that last number that you got is the remainder. So we're going to have a remainder of 8. However, I don't really like writing it that way. If you recall back in Expo, the way that we really prefer it is this means 46, and then that remainder is still being influenced by whatever you were dividing by. So it's actually going to make a fraction with whatever you were dividing by. So that remainder of 8 really means 8/11ths. The neat thing is we can apply this to polynomials as well. Okay, so if you look at our next example, we're going to follow the same process with polynomials. Now, when we're looking at this, at polynomials, I'm focusing on those first terms, okay? Because I want to cancel this term by term, kind of like up above, we were canceling number by number. So what I want to do is I want to figure out what can I multiply that x by for it to be able to cancel the 4x squared, okay? And what I'm saying is it's going to need to be multiplied by 4, and it needs another x. X times 4x will give us the 4x squared that we're going to be using to cancel. All right, so now if you recall, that 4x is now going to multiply that whole thing. So I'm going to take that 4x and I'm going to multiply it to that entire x plus 5. And hopefully you can see that type of multiplication, you need to distribute this through. Okay, so far what we have is a 4x squared plus 20x. All right, so once you figure out what you're multiplying by, put that on top. Then you figure out what that means you have, put that underneath. And now we want to see how close did we get. Okay, how close are we to the original polynomial? I kind of already alluded to this, and again, hopefully you remember back from Expo that what you're doing now is subtracting off. You're trying to see how close you get, and you should always see that first term canceling. Okay, so 4x squared minus 4x squared gives me nothing. That cancels off completely. 23x minus, notice that minus affects that term as well. So 23x minus 20x is going to leave me with a 3x. and then you pull down that next piece. So you can see works is starting to work exactly the way that it did just when we had numbers. Now we're doing it with variables as well. And now I start the process over. So now I look at my x and I want to see how can I make it cancel a 3x. Well, an x needs to be multiplied by 3 to become a 3x. So I'm going to put a 3 up there. So once I figure out what I need to multiply by, now let's figure out what that gives me. So I'm multiplying the x plus 5 by 3. And again, just going to distribute that in. So I'm going to get a 3x plus 15. And now let's see how close did we get. Okay, how close are we? And again, hopefully you remember 3x minus 3x. That first thing should always cancel off. Is why we're doing this process. We're taking this thing away bit by bit. Now negative 16, remember that negative also applies here. So negative 16 minus 15 more is going to give me a negative 31. Now notice, x can't go into negative 31, okay? And also there's nothing else to pull down. So what that's communicating to me is that this negative 31 is the end game, okay? That is that remainder that we're getting. So I have a remainder of negative 31. However, just like I pointed out up above, we really don't like to write it that way. That's really not that meaningful to me. So what I really want you to do is write it as that divided by whatever you were originally dividing by. I want you to use that as a fraction. Okay, so that is going to represent the polynomial, okay, the solution when we divide those two things. So let's take a look at a little bit bigger example. So now let's work with a cubic function, dividing that out. So when I take this, again, the first thing you want to recognize is how to write this. So I'm going to take that x plus 2 on the outside, and I'm going to put what is being divided on the inside. And we need to set this up where I want that x to be able to cancel that x cubed. Well, what does an x need to become an x cubed? Well, that x is going to need x squared to become that x cubed. All right? So once you figure out what you multiplied by, now it's time to figure out what you've got. So we have x cubed, and we need to multiply that into the x plus square or x plus 2. So let's distribute that to see what we have. What we have is an x cubed plus 2x squared. All right, so once we see what we've got, now let's see what we have left. So I'm going to take this and I'm going to subtract it off to see what we're left with. How close did we get? The first thing, once again, should always cancel. All right. Then we have 7x squared minus, remember that minus influences that, so minus 2x squared is going to leave us a 5x squared. Then we pull down the next piece. Once we pull down the next piece, now we start over. So now we need to see, what does this x need to become a 5x squared? Well, it's going to need a 5, and it's going to need an additional x. Okay, so I need a 5x this time to turn that into what I need. So take that 5x. Now let's see what we've got when we multiply that to the x plus 2. So what we've got is 5x squared plus 10x when we distribute that through. So now that we see what we've got, now let's see how close we were. How close did we get? Again, that first piece, 5x squared minus 5x squared, that always cancels, okay? You always want to make sure you're removing this piece by piece. 14x squared minus 10x, or sorry, 14x minus 10x. Going to leave me with 4x. Pull down the plus 3. And in this instance, you may notice we can actually keep going. All right, so here, now let's see, what does an x need to become a 4x? Well, it's going to need a 4. So take that 4, multiply it to that x plus 2. So that's going to leave us a 4x plus 8. So now that we see what we have, now let's see how close we were. Again, that first term should always, always cancel. 3 minus 8 leaves us with a negative 5. Okay, so that negative 5 is going to be our remainder, but again, we don't want to write it just with that r. We want to show that the remainder is still being influenced by whatever we were dividing by. So by that x plus 2. All right, next example. So again, we just want to make sure we're familiar with the setup. Whatever you're dividing by, oh, sorry, I thought you meant x minus 3. Whatever you're dividing by goes on the outside. Whatever is being divided goes on the inside. And let's work through the process. So I want to see what will allow that x to cancel a 2x cubed. Well, it's going to need a 2, and then I'm going to need 2 more x's, so an x squared, to give it the right exponent. Okay, so I need a 2x squared here for that x to become a 2x cubed. So now that we see what we're multiplying by, now let's see what that gives us. Okay, so I'm going to multiply that into the x minus 3. That's going to give me 2x cubed minus 6x squared. And now, of course, let's see how close we got. Okay, let's see how close that leaves us. 2x cubed minus 2x cubed cancels off, just like we know it should. We always should lose that first term. Negative 2x squared minus a negative 6x squared. That negative here is going to make that a plus, right? It influences that second sign. So negative 2x squared plus 6x squared will actually give us a 4x squared. And then subtract the 5x. Once we have that, now we start the process over. I go back and I focus on how is that x now going to become a 4x squared. So you can see you're going to need a 4, and the x needs one more power. So it needs another x in it. Once I see what I'm multiplying by, now I want to see what that gives me. So I see that that's going to give me a 4x squared minus 12x. And of course, when you see what you have, now let's see how close that gets us. 4x squared minus 4x squared cancels off just like we know it should. Negative 5x minus a negative 12x. Remember, that negative is going to make that a positive. So negative 5x plus 12x is going to leave us a 7x, and then pull down that 7. Let's do the cycle again. What does it take to make an x a 7x? Well, I'm going to need a 7 there. So now that I see what I'm multiplying by, now let's see what that leaves me. So multiply that in. So I'm going to need to bring this down a little bit. 7x minus 21. As always, let's see how close that gets us. So, where does that leave us? Well, that cancels off just like it should. Minusing a negative 21 is actually going to make that a plus. So 7 plus 21 leaves us with a 28. I have nothing more that I can pull down, and x minus 3 obviously cannot go into 28. So that means that is the end of my process. That 28 is my remainder. By remainder, that means it is still being influenced by whatever we were dividing by. All right, so why don't you flip the page for me again? So another example. So here we have 2x plus 1 that we're dividing by. And we have 6x squared plus 7x plus 2. So let's begin our process. So we have 2x. We want to know what is it going to take for that to cancel a 6x squared. Well, 2 times 3 is going to give us 6, so we know we need a 3, and the x needs another exponent, so it needs another x with it. So we get a 3x up there. Now let's see how close did we get, or what that leaves us with. So when I multiply that in, that gives me 6x squared plus 3x. Now, let's see how close we got. 6x squared minus 6x squared is done. 7x minus 3x leaves me with a 4x. Then I pull down the 2. Let's start this over. So, 2x, what does that need to become a 4x? Well, 2 times 2 gives me 4, and the x doesn't need any more exponents. So I just need a 4 there. And let's see what that leaves us with. So 2 times 2 plus 1, or 2x plus 1 is going to be a 4x plus 2. And this time you can actually see something neat kind of happen. 4x minus 4x, 2x minus 2x. This time you have no remainder left. Okay, I'm ending with a 0 there. So here there actually is no remainder piece. And something actually really cool happens when you get this. When you get a remainder of 0, it means that the divisor is a factor of the dividend and can be written as. So basically that's just a fancy way of saying that 6x squared plus 7x plus 2. What it means is this actually factored it for you. When you're left with a remainder of 0, it means that 2x plus 1 was a factor of that polynomial. Okay, it was a factor of it, and what you got left was the other factor. So that's kind of the cool thing. Remainders of 0 actually shows you that what you were dividing by is a factor of that original polynomial, and that what you had left is the other factor. All right, that's going to become really important in section 5-6. So do make sure that you kind of keep that in mind because it is going to come back in our next section together. So I have one more thing that I want to go through. So what if a term is missing? Okay, so for example, when I go to set this up, I have 2x minus 5. When I go to set this up, 2x cubed minus 9x squared, you'll notice there's no x term there. All right, when you notice that there's a term that's missing, I want you to represent it with a 0. So here use a 0x as a placeholder for me, please. Other than that, this process is actually exactly the same as what we've been doing, okay? Now there's no difference. So run through the process. So what does 2x need to become a 2x cubed? Well, the 2's already match, so that's not a concern. But the x needs 2 more powers to become an x cubed. So that tells me I need to multiply by x squared. Multiply that in. That's going to give me 2x cubed minus 5x squared. Once I see what I've got, now I want to see how close am I. That first thing should always cancel, right? Negative 9x squared minus a negative 5. So remember that is going to change that to a plus. Negative 9x squared plus 5x squared is a negative 4x squared plus that 0x, okay? Still pull that down. Now we work on the process again. So what does 2x need to become a negative 4x squared? Well, 2 times negative 2 will give me the negative 4, and the x needs another exponent. So I know I need an x up there. So this time I know I need a negative 2x. So distribute that in to see what we've got. So we have a negative 4x squared plus a 10x. And of course, now let's see how close are we. Negative 4x squared minus a negative 4x squared. Remember that negative, it's going to change that to be positive. So that cancels just like we want it to. This negative also makes this negative. So 0 minus 10x will be a negative 10x. Then pull down the plus 15. And now we're going to have to do this one more time. What does 2x need to become negative 10x? Well, 2 times negative 5 will give me the negative 10. And then, of course, the x's already match. So all I have to worry about is that negative 5. And now I need to see what that gives me. Gives me negative 10x plus 25. Subtract off to see how close you got. Remember, this negative will flip that sign. So those do in fact cancel off just like we know they should. 15 minus 25 will leave me with a negative 10. Recall here that when you have something left behind like that, and now 2x can't go into negative 10 at all, so that negative 10 is simply our remainder. Always write your remainder still being divided by whatever you were originally dividing by. And so that is going to be our answer. So thank you so much for joining me for this. I apologize it got a little bit longer, but there's a lot of good conversation to have about long division. So do make sure you take a moment to write that summary for me and then come back to class ready to do your practice work.